So I will remember that this call is being recorded and we'll place our recordings on our YouTube channel. If you don't want it recorded, you may want to drop off now. So once again, good morning, everyone. Thank you for joining for the session of Azure Power Lunch. We are going to be talking about Azure Elastic SAN, which is currently in preview. And if you don't mind, yeah, thank you. Um, and here is a quick agenda. As usual, we are going to be talking about what is a SAN, quick overview, 1 minute, just to be set the stage, and then what is Azure Elastic SAN, what it brings to the table. We'll look at some of the benefits. Mostly it's going to be demo, but there would be some slides since we need to have a quick level set on some of the key concepts. Okay, what is a storage area network? It's a collection of pooled devices accessed through a high-speed network. So machines can connect to it just like they connect to local disks. That's what it is. It's to address your mission critical workloads. Normally, organization that is very popular in on-prem data centers where you buy a SAN infrastructure, shared area network infrastructure, storage area network infrastructure, and you buy it, you install it, set it up, and then carve out um, spaces or basically storage for your mission critical workloads. Okay. Normally, the process is that you have to order it, you have to set it up, and then you have to kind of take care of it because since it has physical infrastructures like network cables, disk, something goes bad, then you are responsible for it. So that's kind of what is the storage area network. Let's talk about what is Azure Elastic SAN, what it brings to the table. So Azure Elastic SAN is Microsoft first party uh, storage area network service in the cloud. You don't have to, it's built on top of Azure Storage. If you know, Azure Storage is Microsoft's storage as a service, which is available in the form of block blobs, in the form of file, in the form of queue, table, and data lake. So this is an offering built on the same scalable, highly available, highly scalable infrastructure, which provides the SAN capability into the cloud. So you don't have to provision um, any hardware or anything, just like everything else in the cloud. You just type a command or click a button on the portal, and your storage area network will be created for you. And once this is there, that you can carve off, you can create volumes, which is we will talk about in a seconds, which is basically storage shards, and you can attach it to your workloads that can be virtual machines, that can be AKS running in the cloud. So you can, that's how you can use it. And one of the key advantages that it gives you up to million of IOPS at the same time with latency, which is kind of a single digit latency, millions of IOPS, and gigabits of throughputs. So um, that's the goal of the Azure Elastic SAN. Okay, and we will look at some of the key terms. So first of all, what is the Elastic SAN? It's a top level Azure resource first party service, as I say, that is available in public preview at the moment. Okay, what are volume groups? And if you are familiar with a SAN appliance on-prem, just I want to have this picture just to compare like how these things kind of compare to one another. So with the volume groups, you create volume groups for control network access to different volumes. So for example, take a step back. So you create a SAN for your mission critical workload. They can come from different application, different teams in your organization. Okay. And you want to make sure that each team can access their own storage area network storage in the storage area network that you have created. In order to do that, you create volume groups in Azure and what in a storage area network. And what these volume groups do, you can put network restrictions on it. You can create a private endpoint, or you can create what we call service endpoint. So basically, allow a network, a subnet access to that particular volume group, and whatever access that is, it applies to all the volume. So think of it this way: that you can then assign. So you can say this volume group is for app A, this is for, you know, app B, C, and D, and they are running in a certain VNet, and you have given access to the subnets in that VNet or to that volume group, and they can use it. So everybody works with their own storage volumes. That's how kind of a volume and volume groups work. Any questions? Okay, now I want to spend a couple of minutes on what features of storage are supported. First of all, I want to be, if you haven't noticed, iSCSI is the protocol that is at this moment available to connect to this storage area network. Okay, so just keep that in mind. Encryption at rest is available. It is at the moment through Microsoft Managed Keys. We are using Storage Service Encryption (SSE), and that's I'm using Microsoft Managed Key. So data is encrypted at rest. Okay, um, and it's using for the access. It's using iSCSI protocol. In regards to the redundancy, you have locally redundant as well as ZRS available. Depends on what region, and we will take a look at it in a second. Okay, private endpoints are supported at the same time. You can allow access to certain virtual network which used to be known as service endpoints. Okay, and then soft delete and snapshot are not supported. Okay, this is a slide, and you don't this. And by the way, just want to be very clear on that. Everything that I'm providing in the slide is available in the documentation. I just put it in the slide because sometimes it's easier to mention that going through document pages. But you can take a look at it, and this is available. This is nothing I'm sharing which is proprietary or NDA. It's all public information that is available. So just want to mention here, and we will take a look at once we do the demo. I will explain some of the things that I mentioned here. Um, for example, in certain region, you have like, for example, France Central, the maximum IOPS that you can go to is 500,000 per SAN. So that's a provision IOPS. In on the other hand, in East US 2, you can go up to 2 million IOPS. Okay, and you can go up to 32 gigabits per second of throughput. Okay, if you are using ZRS, which is available currently only in the 4 region mentioned, then their limits are slightly different. Okay, so just keep that in mind as you are, and you know the service is currently in premium. And okay, we will come to the pricing in a second. I just want to go through a quick demo and want to show you something there, which is, I'm sure, will be of interest. So let's start with that. Okay, so what I'm going to do is I'm going to create a Elastic SAN. Any question at the moment? Okay.
Hey, Naveed, I
Yes,
have a
please.
quick question. And first
Yes.
off, thanks for your faithfulness in doing this every week. These talks are great. But what my question is on AKS access. Does this use the CSI drivers to be able to mount this SAN? Do you know?
That's right. Yes.
Okay.
As far as I know, that's true. But if anything is different, I will, you know, post it in this chat. So this is so what we are creating is a SAN. This is the name of the SAN, and we are just going to be doing South Central. This is zone one, blah blah. Okay, this is probably one of the important thing to remember. Minimum capacity of a SAN has to be is 1 TB, and with 1 TB you get 5,000 IOPS. Okay, this is the provision IOPS. So you can have in each so you can have many volumes, but just keep in mind that the collected IOPS of those volume cannot cross 5,000. So let's say that one volume is using 2,000, one volume is using 3,000, 5,000, it's okay, but it cannot cross 5,000. So if you have like four volumes, each is using 500, all good. But as soon as you start hitting that 500 mark, uh, you will be throttled. So that's something to keep in mind. Okay. So let's say that you want 50,000 IOPS and or yeah, you want 500,000 IOPS. So you provision 100 TB. Okay, because that's drives base will drive your IOPS and your bandwidth. But let's say that your IOPS requirements are the same, but your storage requirements have increased. You are still using the same IOPS, but you need more storage. So you don't. So what you do optionally, let's say that you need 100 TB more. So total of 200 TB with 500,000 IOPS and 8,000 megabits per second. So you see what I'm saying? Your additional storage will not increase your IOPS. It's cheaper. The price of additional storage is cheaper because there is a reason. It doesn't impact your IOPS. So that's where, I mean, that is a very important piece of planning that you will have to do, that you can go in and you can set that up. Just keep in mind, you can increase that in the future. So you can change that. And but you cannot decrease it. So let's say you set up for 100 base IO, 100 base storage, and then you thought, oh, I don't need that much. You cannot come back. I mean, you can go up, but you cannot go down. Just keep that in mind. And once again, just want to mention it, base will drive your IOPS and your bandwidth. On the other hand, the additional is just additional storage capacity. It will not impact your IOPS or your bandwidth. Got it? Okay. So that's that. So that will give you like this is your provision IOPS. And let's go to the next screen and let's create a volume group. Just keep in mind that volume group is nothing but sorry, I can't type today, demo VG1. Volume group is nothing, just a way to control access to the volumes underneath. Okay, so you have to do one of these things. You can do both. You can do virtual network or private endpoint. Okay, so what I'm going to do is I'm going to select a virtual network. I'm using this one. In that, I'm going to use VM subnet 1. It's going to ask, yeah, do you need to enable it? So now I am allowing access from this subnet to this volume group. That's it. Okay. And at this moment, I can create. And let's now go to the volumes. Okay. So what are the volumes? So we have max capacity of 200. Just keep in mind the maximum capacity. I know we have provisioned 500,000 of IOPS, but your volumes cannot go beyond 64,000. Very important point to keep in mind. The max IOPS that your volume can have is 64,000. That's it. Okay, so that's another thing to keep in mind. So let's say that I am going to create a volume one. I'm going to call it WinVol1, and it's on this one. And I'm going to put the size, let's say 1 TB, it's 750. If I do 10 TB, it's 7500. But if I do 100 TB, look, it's locking at 64,000. It's not gonna go beyond that. Okay, no matter what you do. If even if I go, I think to let's say 80 terabyte or 90 terabyte, it's still 60 or 90 terabyte. It's gonna be still 64K. So that's the max IOPS that I can get, and the max bandwidth or the throughput megabits per second. It's capped at uh, 1 gigabits per second or 1024 megabits per second. Got it? So that's the limit that's being set. Okay, so let's do that. And then we do next, and that's gonna create a Elastic SAN. I mean, we can add tags. I'm not gonna go through that. I already have an Elastic SAN created. So what we are gonna do is we're gonna take a look at that. This is my Elastic SAN, and as you can see here, there are two volume groups. First of all, quick overview. This is the SAN. And I'm penny pinching in the cloud, so I only have 1 TB. This is just for the demo. And this tells you like how you connect volumes and things like that. Just general stuff. This is the configuration. And once again, I can increase both the base and the additional. This is great. Think of it. I mean, if you have this thing on-prem, I'm sure a number of us have seen this with our customer or the organization that we work with, where we have SAN and it wasn't easy. You have to upgrade it, and that's a whole process here with just a script. I mean, I'm just showing it through a UI or from through the portal, you can increase the size. Just keep in mind, you cannot go back. Okay, you cannot decrease the size. So that's the important piece. Okay, so that's that. And then there are volumes and volume groups. There are two volume groups that I have, and then I have these volumes. Okay, so what I'm going to do is I'm going to add another volume and just want to show you how we can attach this volume to a Windows machine. Okay, so we're going to call it Win Volume 5. I'm going to call it 32 GB. Okay, so let's do that. And with a click of a button in a second, it's going to create that volume. Okay. Wait for a second. Okay, so once that volume is created, what we are going to do is we are going to attach it to a Windows server that we are running. And give it a second. Okay, so that has finally created. We look at this volume. This is the volume. So the first thing you have to do is let's go into the, hold on a second. Let me go to my console. So this is my console. And what I'm going to do is I'm going to run a command here. First of all, Control C, Control L. I'm going to run a command which gives me the information. And by the way, this all stuff is documented. You can look at the sample. So I'm not kind of sharing anything which kind of non-documented or only I know. It's all documented stuff, but it's just I'm sharing it as a part of the demo. So what I'm going to do is I'm going to take these three things out, and this is the information that I need to connect my machine to this volume that we have created, because my machine is running in the same VNet. My virtual machine is running in the same, it's a Windows server virtual machine running in the same VNet. Okay, so let's quickly go there. This is the Windows server. As you can see, I was playing with it, so I already have two volumes attached. I haven't done anything with them, but they're two attached. So just keep that in mind. And this is the um, I have this PowerShell, and I am using. And by the way, uh, what you will be using is the iSCSI client, which allows you to play with iSCSI volume. A detailed discussion about this iSCSI CLI client is not as a part of this discussion. Please, there is great documentation available if you want to take a look at that. But in this one, what we are doing is we are just going to be using this to attach it to our VM. So first of all, these are the three commands. So I'm going to update these three values. First is the target IQN. So that's that. And this is simple copy and paste. And these commands are available as a part of the documentation. So you just update these values. The second part is the host name. So we are going to go in and change the host name as well in all three commands. And I will explain what these three commands are doing. Give me 1 second. Let me just do the pasting, and then we will go from there. Okay. So the first command is basically adding a SCSI target. That's what it is doing. So let me run the first command. Yes, as you can see here, I hope everybody can see it. It has started the added the target. Okay. Second command is logging into the target. It's a login. So login is there, connection ID created. Third command is interesting. It is persisting the connection. So what if you don't run this command, it will attach now, but the next time you start your machine, the volume will not be attached. That is not a very good experience. So let's do that. And once we do that, all three operations are completed. If you remember, there were two unused volume. Now there is a third one. You see that? And I can format it, I can use it. So my point is just look at it. In a few simple steps, we have provision our SAN, we have created volume groups, volumes on it, and attach it to a machine. You know, and if you're doing it on-prem, I mean, I think the time that you may not be able to kind of submit an order to order the to get the hardware. So that's the power of the cloud. So any questions? Okay, so now I'm gonna talk about in the next 5, 6 minutes. This is a very good example on the performance side to understand. Okay, and one other thing is I forgot to mention. Sorry, it uh, SAN allows you to bypass the throttling requirement of your VM. You know your VM, since it's using iSCSI. So let's say your VM has a certain IOPS pipe, you can bypass that. So you can cross that threshold. So a VM may allow, let's say, 7,000 IOPS, but with your volume, if it has 64,000 IOPS, since you're using iSCSI, you will be able to bypass that. Got it? So that's another advantage. So now let's look at this example configuration. Let's look at the your workload first. Your workload, you have different workloads. You have VMs and AKS. AKS has 5,000 IOPS limits. That VM has 48,000, 51,000, 76. All that. Okay. Now you are running a SAN with 25 terabyte, which gives you approximately 135,000 IOPS. Just keep in mind, combined IOPS of all volumes in all volume groups running on the SAN cannot cross 135,000. Just keep that in mind, okay? So the max IOPS, basically the AKS SAN, all of these volumes can go is 64K. So first scenario, your workloads are running, requested IOPS are 3,000, 10,000, 8,000, 20,000. Total IOPS, how much they are? This is like 39,000 of total IOPS, still below 135,000, still below 64,000 per volume. Everything is good. It's a smooth sailing. you know, no throttling, nothing. Everything is going as planned. And now we have a spike. So let's see. There is a spike on workload 3, 64,000. 64,000 is 64,000 is the requested IOPS. Okay, 64,000 is requested IOPS, and the spike happens. And since it's the max IOPS, and look at the other one, 64, 20,000, 84, 86,000, still below 135,000. So spike will be good, no problems. One workload is spiking. Normally, that's the case. One or two workloads normally spikes. Rest workloads are that. But let's say that we are in a worst case scenario where you have all workloads are spiking. So now you have 5,000, 40,000, 45,000, and 64,000. Simple math. You are going beyond 135,000. Now it's gonna start throttling. Okay, so this will be the served IOPS like 5,000, 90,000. So you see what I'm saying? So and look at the time. Whatever comes first will take the majority of the IOPS, and then what comes second, that will not. I mean, that will be throttle. So this is kind of what will happen. This is just to explain how the kind of a SAN IOPS limit, volume IOPS limit, and spiking will play, and something to think about. Any questions? So just want to do a quick recap. So go back to the slide and quickly look at some of the benefits. Since I mean, since it supports iSCSI, so it's kind of a variety of compute resources that can be used at the same time. It allows you to buy up the IOPS limit of Azure VM since it's using iSCSI. And in regards to cost, as I mentioned here, um, if the base unit, since base unit is driving your IOPS and your throughput, that is more expensive than your scale unit. So as you add more storage without increasing your IOPS, that is less expensive, as you can see, compared to your base storage. Okay, so that's that. So I mean that's all I have for today. I mean we have one more minute. So any questions? So with that, we are right on time. Thank you for joining, and hope to see everyone in the next Azure Power Lunch session. And hope everybody had a wonderful rest of the day and great weekend.